Hello, everyone. I'm Kiran Gollu. In this talk, I'm going to focus on our journey of architecting Prometheus for cost efficiency. If you look at the state of art today, people typically over-provision the CPU and RAM in response to query timeouts, out-of-memory issues, and HA. Most observability tools were not architected for cost from day one, although there were several attempts at handling scale first, thanks to Thanos, Cortex, M3, Mimir, and Victoria metrics, primarily using disks and S3 for long-term storage. And a lot of them have also tiered storage, hot tier, expensive, and then it could be SSD-based. And if you store the data in cold tier, it could be, again, S3, but access is slow. And a lot of them have the properties of lift and shift on-prem architectures. We'll also cover the demo at the end of our product, what we launched. If you were to start from first principles, is it possible to architect for cost and scale from day one? So that was the question that we asked ourselves. And also, is it possible to get 10x more efficiency in storage, compute, and network? And also, is it possible to leverage truly cloud-native primitives, much like what we saw in Snowflake and Databricks worlds in the data warehousing space? And we're also curious about how will this impact the query performance as well. So how did we achieve 10x lower compute, primarily leveraging serverless? You don't pay for compute when you're not using it, and only when you're using the compute is being leveraged. We also leverage some caching. And on the memory front, we don't have any global indexing, and we have a custom in-memory representation. On the storage front, what we did was, what if you don't have any SSDs, just store everything in S3 or equivalent object storage, you'll be able to achieve 24x lower storage, assuming a three-way replication. So we were able to achieve downsampling as a side benefit of this. Most observability tools, in fact, metrics, they downsample the data. If you want to get to 30-second granularity or 15-second granularity, you lose that. We're also able to achieve zero networking costs with a AZ-aware architecture, especially if you're hosted on the cloud. When the sender or the OpenTelemetry data goes through an availability zone, you can actually pin the availability zone across sender and receiver and directly write it to S3 so that there are no egress costs at all. Egress costs are down to zero. So that's something that we have leveraged. So where did we land? Is it possible to architect for cost and scale? Absolutely, yes. And we were able to achieve some pretty cool performance as well, less than 3 seconds. So serverless and S3 is the way to go. It's truly cloud-native architecture, and we're also able to achieve 5 to 10x cost efficiency and also pretty cool performance. Let me briefly show you what we launched. If you want to play with it, it's available at play.oodle.ai. And let me just show you the screen here. We're ingesting about 14 billion data points per minute and about 15 million time series per hour. Prometheus typically starts to hit some scaling problems, 1 to 2 million. We're ingesting about 3 terabytes a day. You can see the performance is pretty snappy. You can actually play with that, different queries. You can see that, and all of this is available live if you want to play with it at play.oodle.ai. We leverage serverless, S3, pure object storage, no disks at all. Thank you very much.